Hello, this is Mr. Agbamu Idanogwene. I'm here to teach mathematics on the topic coordinate geometry. And in today's class, I'm focusing on the following objectives. Calculate the gradient of a straight line joining 2 points, and calculate the angle of slope of a straight line. So all I'm going to do in today's class is to show you how to calculate the gradient of a straight line when 2 points are given on the line. Then how do you get the angle of slope? Okay, let's go straight to the point. Gradient of a straight line is very simple to calculate, and gradient is a very important concept in science, especially when it comes to plotting of graph in physics. You need to calculate the gradient. Gradient and slope, they mean the same thing. They can either tell you to calculate the slope or they can tell you to calculate the gradient. But in this topic, coordinate geometry, all you need is to have 2 points on a straight line. Then with the 2 points you can get the gradient or the slope of that line, or you can be asked to find the angle of the slope, which is the same thing as angle of the gradient. That is all we shall do in today's class. But the simplest way to understand what a gradient is to follow the simple definition. A gradient is simply just a gradient is simply increase in y. This is a simple way we use in defining it. Increase in y divided by increase in x. Increase in y divided by, use this symbol, divided by increase in x. So this is just a simple way to define gradient. So what increase in y means and increase in x means is just telling you how is y changing with respect to x, or how is how is y changing in respect to x. That is what this statement means. Increase in y divided by increase in x, or some people can call it changing, or they can say change in x, change in y. Some will say change in y divided by change in x divided by change in x. So this is the two statements most people use for gradient. But we don't need this when we want to calculate. We need to get the actual formula so that we can use it to calculate. But this is a simple statement we use in describing gradient. Increase in y divided by increase in x. Let me also demonstrate this using this so that you can understand what we mean by increase in y divided by increase in x. So if I have my point, my two coordinate x1, y1 coordinate, you can see it clearly here, x2, y2 coordinate. And let me show the 2 points on the graph sheet. You can see the 2 points, the first coordinate, which is point A, the first point which have coordinate of 2 and 1. You can see it, x1 and y1, you can see them. Then x2, y2, you can change their position if you wish. You can see as I'm moving the point, see the slider is also changing. Okay, let me put it in this place. I think you can view it clearly here. Let's say the second point is 8 and the second coordinate is 8 and 6. Then the first coordinate is this. Let me take this. Okay, this is okay. Let's put it here. Let's say 3 and 1. This is the first coordinate, which is point A. So when we say gradient increase in y, what do we mean? Now look at this straight line connecting A and B. So this is a straight line. So how is y changing from A to B? That is what gradient is talking about. So let me put a point on this line so that we'll see something. If I have a point which is labeled as point D here, so you can see, let me slide point, okay, let me put D at A. So this is point D. So D is moving now. You can see D is moving along the line. So how is this D changing along this line? That is what gradient is talking about. That's why we also use slope as gradient. You can see that D is moving along this slope. See, this is a slope. You can see it's like you are climbing a hill. can see it, or you can come down or descending or ascending a hill, you can see. So how is D changing with respect to X? So, and as D is increasing, let me put the coordinate of D so that you can see it. So let me put the coordinate so that you can see what I'm talking about. Let's put name and value here. You can see the coordinate of D now. Okay. You can see that D is changing when D was at the lowest point of A. See, it has the same coordinate with A, which is 3. You can see which is 3 and 1. So as D is rising up along this line, you can see it's changing now. You can see the coordinate is now 3.25, 1.25. You can see it. It's changing. So as you keep going, it's changing. So what we are doing in this topic now, gradient of a line, is how is this point changing with respect to X? So how is this point changing with respect to X? And most time we follow it through the two coordinate X and Y axis. So when D was here, 3 and 1, when it rises to this place, see, when it rises to this place now, which is 4, X is now 4, Y is 2. See, it has changed from 3 and 1 to 4 and 2. When it rises to this place, you can see it's now 5 and 3. You can see. So how is it changing? So how is Y changing with respect to X? So that's what we mean by increase in Y divided by increase in X. So if I want to get the gradient of this line, it's easy. All we need to do is to get the formula first. So how do I get the formula? I need to sketch a straight line like this. Let me use a broken line. Okay. So if I join this line, this point down to this place, if I join this point down to this place, you see that a triangle has been formed. You can see that a triangle has been formed. This is ABE, that is the triangle ABE, and this is a right angle triangle because this angle is 90 degrees. Vertical horizontal line, they meet at 90 degrees. So this is a right angle triangle, and this is the point sliding on AB line. So how do we get the gradient? We just need to get the distance. So how is Y changing? Y changes from, you see, Y1 is 1, it changes down to the next point, Y2, which is 6. So how is Y changing with respect to S? If I take D as another point, you can see that Y changes from Y1, which is 1, to another point, which is 4. You can see it, 6 and 4. So you can have so many points on this line. So all we want to do with the gradient is how is Y changing with respect to X. You can see Y is changing from this point A, it changed from 1 to 4. From D, it changed from 4 to 6. The same thing with X. X changes from 3 to 6. It also changed from 6 to 8 along this line. So if you have so many lines, this is what you are going to see different changes. So we want to know the particular change, that particular value of change, that is a gradient, that value of change of Y divided by X. That is what we do in gradient, and in doing that, it's not difficult. All you need to do is to get this distance. What is the distance from B to E? If you know the distance, divide it by the distance from E to A. You know the analysis. If this is x1, you can see it, x1 and y1. So from 0 to here is x1, which is 3. Then from 0 to E, this is x2, which is 8. You can see x2 is 8. So if I subtract 8 minus 3, it will give me this distance AE, which is called x2. So this is x2 minus x1. So that is this distance on this place, x2 minus x1. Then the same thing for y-axis. This is y1, which is 1. You can see it. Then the distance to this place is y2, which is 6. You can see 6. Then if you do 6 minus 1, you will get this distance. So this distance here is y2. So y2 minus y1. So these are the distances of this point and this point. Then this angle can also be found. Just take note of this. You can get this angle. So this angle, let's call it theta. Let's call this angle theta. From your trigonometry, you will discover that y2 minus y1, this distance here, divided by x2 minus x1 is also called tan theta. If you use your SOAP 2 in mathematics, you see that tan is opposite. Theta is facing here is opposite. This point is 90 degrees. No, this is 90 degrees. So where 90 is facing is hypotenuse. So this AB line is hypotenuse. So you can say tan theta is opposite over hypotenuse. So that is why the angle of the slope, we usually use tan theta. And most times we also call tan theta the gradient of a line. If they ask you to find the gradient of a line, you can either use y2 minus y1 divided by x2 minus x1, or you can use tan theta. It's the same result. So tan of this angle you have here will give you the same result. So let's impute it in our write-up, and that is all we have for today, just to do 1 or 2 examples and we are done. So let's see what we have now. So if I go to our write-up now, let me remove this statement. If I go to our write-up, you will see that from our explanation, gradient is equals to, you have your y2 minus y1 divided by x2 minus x1. So this is the formula for gradient. The 2 points will be given. Just take the second point y2 minus the first point y1. Then for x, the second point minus that. That is all. So this is all with gradient. Or if you don't want to use this, or depend if the points are not given, maybe the angle is given, or you can use gradient. Gradient is equals to the angle, which is tan theta. Gradient is equals to tan theta. So this is another formula for gradient. Where theta, what theta means, let me put it in statement. Where theta is angle, is the angle between the horizontal axis, the angle between the line and the horizontal. It's always horizontal, don't use vertical. The horizontal line. So this is the meaning of theta. You can also use this, it's the same result you will get. If you use this, you are getting the same result. So just take note of that. So this angle here, this theta now, if gradient is known now, and they can tell you to calculate the theta. So by getting the theta now, that is the angle of slope of the line. They say, what is the angle of slope of the line? That means you need to get the gradient first. After getting the gradient, then you now find the angle, that is the theta, using this formula. Or they can give you the angle between the line and the horizontal. They will give you the angle, they'll tell you to find gradient. So you can use this also. Or you can just use this directly if the gradient is asked. Find the gradient given 2 points. So you use it. So you use this when 2 points are given. You use this when angle is given. So if we go to what we have here now, let's put our value for gradient. Let's see. You can see slope here. If I select this line, you can see the slope is 1. You can see it the slope is 1. Just take note of that. Or I can get it here, show gradient. You can see show gradient. If I click on show gradient, you see the gradient is 1. What did they do here? They just did, you can see the sketch the system did here. He used this point, he used 4, x1 is, x2 is 4, he used 4 here. You can see where he put his point there, 4 and 2. This is what he used in doing his calculation, because he knows that anywhere the point is located along AB line, any point you have, you can use any point, you will get the same result. So if you use y2, which is 6 minus 1 is 5, divided by 8 minus 3 is 5. So 5 divided by 5 is 1. If you use here also, 4 minus 1 is 3. 6 minus 3 is 3 divided by that. So 3 divided by 3 is 1. So that's why you see the gradient is 1. If you also use this point, x on this point is, x2 on this point is 4. So 4 minus 1 is 3. Then y2 on this point, okay, 4 minus 3, x1 is 3. So 4, which is x2 minus 3 is 1. So you have 1 there. Then 2, y2 is 1. So 2 minus 1 is 1. So you see that you're having 1 as your answer. So if I use this example we have there, they can ask you to find, simple question can come like this. Let's take this as example. Example, they can tell you to find the gradient of the line. Gradient of the line joining, find the gradient of the line joining point, first point, let's take 3, 1, and the second point B. Let me use the example we have here. So 3, 1 is first, the second point is 8, 6. You see that the gradient will give us 1. That is what we are doing here, which is 8, 6. So all you need to do here is just to say gradient. Gradient is equals to second point, which is y2. So 6 is the second coordinate here. So 6 minus the second coordinate of the first point here is 1. 6 minus 1 divided by then 8 minus 3. So that is all. Then you do your simple mathematics, you get your answer. So that is all with that. So final answer, gradient will now be equals to, so 6 minus 1, you get your 5. 5 divided by 8 minus 3 will give us 5. You can see. Then 5 divided by 5, you can see that gradient is equals to 1. So this is how you find your gradient. So that is that. Or if you know the angle, let me put this angle here. Let's see. If you know the angle there, let's get the angle. The angle between this point and this point, this line and this line. You can see the angle is 45 degrees. See, this angle is 45 degrees. Let me hide my gradient. See, this angle is 45 degrees. So if the angle is given, just find the tan of this angle, you will still get the same thing. That is what we are talking about. So if I find the tan of the angle, I will get that. Or let me use this. Since I know that gradient is 1, question can say find the gradient of the line joining point A and B and the angle. Question can come like this, and the angle of slope. You can ask a question like this. I can tell you to find the angle of slope and the gradient. So if I want to get the angle of slope now, angle of slope, so this is the formula we use. So where theta is the angle between the line and the horizontal, and this is the angle of slope. Take note of that. Let me just put it in where so that you will not forget it. where theta is the angle between the line and the horizontal line, and is called angle of slope. So take note of that. So that is theta. So theta is called the angle of slope. So if I want to get the angle of slope, you can see that in this sketch, the angle of slope is 45 and the gradient is 1. You know, we have checked it, the gradient is 1 with the system. You can see it, gradient is 1, that is this. You can see the gradient is 1. Then the angle of slope is 45. Let's solve it and see. You see that we'll get 45. So take note of that. Then if you want to get the angle of slope, you need to calculate the gradient first. Now that gradient is 1, all you just need to do is 1 is equals to tan the angle there, tan theta. So if 1 is equal to tan theta, then you need to find the inverse of this tan. So by the time you find the inverse of this tan, you have theta. You have theta will now be equals to the inverse, right? The tan inverse. So tan inverse of 1. So what is the tan inverse of 1? Tan inverse of 1 is going to give you 45. You can use your calculator and check it if you are not too sure. All you just need to do is under your trigonometry, so this is your trig, you get your tan inverse. This is tan inverse. Press it in your calculator. You see the symbol. You press your 1, close your bracket, then press equals to. You see, let me see. Tan inverse of 1 is giving us 90 here. Okay, tan, I'm using sine, sorry. You see tan inverse, so it's tan, not sine. So tan 1. So tan 1, you press your equal to, you see it's 45. So that's why that angle is 45. So the angle here is 45 degrees. So that is it. So you can see why we got the angle of slope in this place as 45 degrees. So also in this place 45 degrees. So this is how we find the gradient of a line and angle of slope. Take note of that, is very, very important. So this is just introduction to gradient. There are so many things you can do with gradient. So with this video, this lesson, you can know what gradient means, so that when we get to other aspect of gradient, we shall be talking about this tan theta as gradient. We shall be using this formula and this other formula more often. Then another thing I would like us to know before we go is, we use most times, the symbol we use for gradient most time is m, but let me not say anything on that. When we get to the next aspect of the topic, we shall focus on that. So that is why you see the system here. When I show gradient, you put m equals to 1. So m is mainly the symbol we use in representing gradient. So we shall talk more on that in our next class. So that is the end of today's class. I hope you understand all we did today. Gradient is y2 minus y1 divided by x2 minus x1. And these are the coordinates of 2 points on the line. Just pick any 2 points on the line. Subtract the second coordinate y2 minus y1 divided by the x coordinate x2 minus x1. Any point on this line, you will get the same result. Or if you know the angle on the angle between the line and the horizontal, if you know the angle, find the tan of the angle, you get your gradient. So that is that for today's class. Okay, so if you wish to study more problem, I know as a student you always have interest to practice more. Practice these following questions. So I have just 3 questions here. So I have point A, B, I see their coordinate. I say find the gradient and the angle of slope. So the gradient is y2 minus y1. Second coordinate 6 is y2 here, 2 is y1 here. The minus 4 is x2, 3 is x2. Then subtract and divide, that is all. Your answer can be in decimal or in fraction, anyhow you wish to leave it, depending on what the question wants. Then the angle of slope, after getting the gradient, you now find the tan inverse of that gradient. That is how you find the angle of slope, which is this. So take note of that. So that is all for today. Do have a nice day and take care.